Hi, this is Lawrence Orijuela, your instructor for CSE4010, Contemporary Computer Architecture, and this is the accompanying video for Lab1. So before I go over this, I'm going to go over this. So here are some lab guidelines. These are going to tell you how the labs are going to go down. So what are the labs? All the labs will have a Part A and a Part B. I will post videos on Canvas showing how to do Part A. Part B must be done on your own using what you learned in Part A. If you do not do Part B, I can only give you half credit. If assistance is needed in the labs, you can reach out to me via email or Discord. All lab submissions must be done using the lab report template that I have provided on Canvas. You can submit your report in Canvas in the Canvas submission page when they appear. The content of the labs. The purpose of the labs is to give you an understanding of how to code in Verilog. The ultimate goal is to write a Verilog circuit that simulates the MIPS data path. So if you want to see what the lab report template looks like, it's over here. This will be posted on Canvas as well. So I would like it if you put your name here, your student ID, say what number lab this is, and then the reports will go here. The source code for A and B will go here. Any screenshots will go here. Okay. After you do everything, I would like it if you could export this as a PDF and then upload it to Canvas. PDF is preferred because depending on what document, like Word program you use, the formatting might be slightly different. So PDF is preferred. Now, let's get down to it. Let's do Lab 1, shall we? Now, like I said before, I will only do Part A for you, and then Part B you should do by yourself. But after you do Part A, doing Part B should be relatively easy. Now, this might look like a lot for a first lab. It's really not. In fact, you might get through this relatively quickly. So here's what the Lab 1 says. Okay. So, Verilog is a hardware description language, a textual format for describing electronic circuits and systems. Applied to electronic design, Verilog is intended to be used for verification through simulation, for timing analysis, for test analysis, and for logic synthesis. So, you might have used Verilog before in some other classes. Maybe you're good at it, maybe you're not. Either way, I think you might find this lab very useful to you. Verilog is what we will be chiefly using in this course. It is useful to us because it can simulate the kind of underlying circuitry that exists inside of a computer. In this lab, you'll work with Icarus, Verilog, and Visual Studio Code. Okay. Now, the reason I chose Visual Studio Code is because you know this class is online. I don't know if you're using Mac. I don't know if you're using PC, but Verilog and Visual Studio is compatible for both. And that's why I chose that. So let's get down to business with Part A. So here's Part A. Part B you can do on your own, but I will do Part A for you. And all you need to do is watch this video and code along with me, okay? It can't get easier than that, right? So the first thing we need to do is download Icarus Verilog, right? We will use this link if we're using Windows, or this link if we're using Mac, okay? So, as you can see, I'm using a PC, so I'm going to click this. Oh, actually, let's open this in the new tab. Okay. So, in order to start Verilog, okay, so in order to install Verilog, you have to click the topmost link, which is this, I believe. Now, I'm not actually going to click on this because I already have Verilog installed on my computer. But assuming you already installed it, all you gotta do is go through the installation steps. So during installation, at Select Components, you gotta make sure that both install min GW dependencies and install GTK Wave are both checked because we're going to need both of those. After downloading and installing, verify that Icarus Verilog installed successfully. And the way to do that is you open the command prompt on your computer. And all you got to do is type the command Verilog in. And if it's installed correctly, it'll display what version of Verilog you have. Okay? So I'm going to type Verilog here just to be sure that it's really there. And surely enough it is. Okay, so some of you might experience an error after installing Verilog. So if you typed the command Verilog and it gives you an error saying Verilog is not recognized as an internal or external command, some of you might get there, some of you might not, but just in case you do, you have to follow all the steps that I listed here in order to bypass that error. Okay. I'm not going to go over this because I'm going to assume that you installed it correctly, but in case you didn't, it's here. But I'm just going to follow the steps underneath. Otherwise, we're going to move on to step 3. Okay. The next thing you got to do is install Visual Studio Code. Now, like I said before, it's available for both PC and Mac. So, oh, my bad. Let's open this in a new tab. Okay. So here it is. So here's the here's the download for Windows. There's a download for Mac as well. Some of you might already have this installed, maybe not. But either way, just install it. Now is the time to make the folders that will contain our labs, okay? So, make a folder, preferably on your desktop. Name it CSE4010 Labs, okay? I'll go ahead and do that. Right here. So, I actually completed all of the labs, and it's under here, under this file called Labs Finished. But I'm gonna go here under Labs Unfinished, and I'm gonna put them here, okay? So open the make a folder for on desktop. Inside that folder, make 6 new folders called Lab1A, Lab2A, all the way to Lab6A. So that's what I'm going to do here. Lab1A, Lab2A, Lab3A, Lab4A, Lab5A, Lab6A. Okay. Now we can begin coding. Let's go ahead and open Visual Studio Code. Let's see. How do I want to do this? Okay. So I think it would be good if I had this over here, and then I had Visual Studio Code on the right. Let me close that real fast. Sorry about that. I had to close that real fast. Anyways, let's make this a little more readable. So let's begin coding. So open Visual Studio Code, which I have here. Open the folder and navigate to the folder Lab1 that you created. Okay. So we're gonna open folder. Now I'm gonna navigate to the place where I put those 6 folders before. Okay. You should do the same on yours. And here's Lab1A. I'll select this folder. Yes, I trust the authors because the author is me, right? So now we will go ahead and create a new .v file. Okay, so let's create a .v file called wiretest.v. You will now create a module called wiretest.v. In Verilog, a module is a block of code that implements a certain functionality. Okay, so I am going to hover my cursor over the Lab1A file in the Explorer pane, which is right here, and I'm going to click New File, and I'm going to call this wiretest.v. Like that. Okay. So inside your module, write the following code. Okay. So here's a module called wiretest. I'm going to go ahead and type this out, and then I'm going to explain to you what this does. Okay. So module wiretest A, B, C. Input A, output B, output C, assign B to be equal to A, assign C to be equal to not A. Okay? And I'm going to finish off. Oh, my bad. We don't need these square brackets here, but what we do need is and module. There we go. Okay, so let me give you a quick breakdown about what this code does. So it's creating a module called wiretest, and it has 3 wires, okay? There's a wire called A, a wire called B, and a wire called C. As specified here, wire A is an input wire, B and C are 2 output wires. Now, I was trying to come up with the most simplest wire I can think of, and this was it. So, what happens is that, like I said before, Verilog is a hardware description language designed for testing electronic circuits through simulation, okay? So the way that this wire is working is that wires have a current going through it, or they don't have a current going through it, right? It has a value of 1 or 0, right? So this circuit has 1 input wire called wire A, okay? Now there's 2 output wires called B and C, right? I set B to be equal to A, and I set C equal to not of A. So that means if the input wire A has a positive charge, like, and by that I mean it has a value of 1, then B will also have a value of 1, right? And then C will have the value of not A. So if A has a value of 1, C will have a value of 0. Inversely, if A had a value of 0, in other words, there's no charge going through it, then that means since B equals to A, B would also have a value of 0, but since C is equal to the not of A, C will have a charge going through it, okay? Now, it's good that I'm explaining to you because part D here, add comments to your code explaining what this code does. Code with no comments receives no credits. And I explained what the code does in the accompanying video, and this is the accompanying video, the one that you're watching now, okay? So go ahead and save your work. I'm going to click File, Save, okay? So now we're going to make a new .v file called wiretest_tv.v, okay? So, _tv, we use that to denote test benches. In Verilog, test benches are used for the verification of the digital hardware design. Verification is required to ensure that the design meets the timing and functionality requirements. Okay, so the fact that we have a module is not enough. A module in Verilog is like a class in C++. Just because you have a different definition of a class doesn't mean that you have a class, right? Like for instance, if you wrote in C++, if you wrote the class for a car has what? Make, model, year. That's just a template, right? You use that to make instances of car objects in your program. Make sense? So in order to use this, we actually have to test this with a test bench, okay? Okay, so here's what we'll do. Hover your cursor over the Lab1A file and click the new file button, which is this, and type wire test underscore tb.v. Okay, press enter. So inside of this wire test.tb underscore tb.v, we're gonna put all of this in it. Okay, so let's go ahead and type this out. So quick note, this symbol that you see here, that is not an apostrophe, that is a grave symbol. It's the backtick. So if you tried running your code and it wasn't working for some reason, you probably put an apostrophe here instead of a backtick. So anyways, I'm going to say time scale 1 nanosecond divided by 1 nanosecond. So this sets the, so I believe that the purpose of this line is to set the time interval for your wire test. Now we're going to say include wire test.v. So wire test.v is in a separate .v file. We have to include it in here. Now we've got to give this module a name, right? So module wire test underscore tb, like that. Okay, so now let's create some wires here. So input wires we're going to denote with the keyword reg, and output wires we're going to denote with the keyword wire. So we're going to say reg A, wire B, wire C, like that, okay? So after we get that, so now we have some wires that we can play with, and let's assign them to our circuit, okay? So what we're going to do now is kind of like what we do in C++. After we make the class for a car, we're going to instantiate an instance of the car, okay? And here's what we're going to do it. Wire test UUT A B C, okay? Like that. So you might be wondering what this is, okay? So you know how in C++ we have data types before our variables? Well, this is kind of the same thing because I am declaring an instance of wire test, okay? I also need to give it a name. I decided to call it UUT, which stands for unit under test, but honestly you can name it anything you'd like. And wire test requires 3 wires, as noted here. The first one is going to be the input wire. The second 2 are going to be output wires, right? So now that we have that set up, we can begin doing this. So you're going to need to say initial, begin, and end. So this sets up your clock to start and your clock to end. I'm going to say $, dump file, wire test underscore tb dot vcd. Okay. And now I'm going to say $, dump vars. We're going to do 0 wire test underscore tb, like that. Okay, so if you're wondering what these 2 lines of code do, it puts the outputs of the results of the tests into a file called wiretest_tb.vcd. Okay? Because after we run it, we want to see the results, right? So after you get that, now here's what we're going to do. Remember, we only have one input wire, which is called A, right? So here's what we're going to do. We're going to set A equal to 0, okay? And now I'm going to say pound 20, okay? If you're wondering what the pound 20 does, it says wait 20 nanoseconds before doing the next change to the wire, okay? So when the program begins, A has a value of 0. What does that mean? It means that B should also have a value of 0, and C would have a value of 1, right? Now I'm going to switch it and set A equal to 1, and then I'll wait 20 more nanoseconds, like that. Then I'll switch it to 0 again, then I'll switch it to 1, okay? So do that twice. And then lastly, I'm going to say this. $, display, and we're going to display a string called wire test complete. We're going to end, and then all modules have to end with an end module. End module, like that. Okay, so perfect. Now we've created our test bench for testing, okay? Now, please watch this video for an explanation of what the code's doing, because you're going to have to put comments for this code. And the way you put comments is with a // same way you do with C++. So maybe you could put a comment here saying these are our wires. Right. Here we're making an instance of wire test. Like that. But honestly, I'm going to leave it to you guys to make comments. I mean, this is your lab after all. Got to give you some responsibility. You got to display to me that you understand what's going on here. Anyways, save your work. So I'm going to click Save All. Now, we're on step 8. We're going through this really quickly now. So after you've written both the module and the test bench and added the comments, we can compile this lab. Visual Studio Code has a built-in terminal, which we use to enter commands. On both Mac and PC, the command to open the terminal is the same. It's control backtick, okay? So I'm going to say control backtick here. All right, so if you use Visual Studio before, not Visual Studio Code, Visual Studio, it's a very powerful IDE, but one cool thing about Visual Studio Code is that it's kind of like a mixture between Visual Studio and the terminal, in the fact that Visual Studio Code has a terminal where you can actually put Windows PowerShell commands in, kind of like you could do with a terminal on the Mac. Maybe Visual Studio has a terminal too, I'm not sure. I never looked into that. But anyways, here's what we got to do. We got to compile the lab. Now, compiling labs always use the following command format. We have to say the keywords iverilog -o. Then we say the name of our test bench .vvp and the name of our module .v. Okay? Therefore, the appropriate command to use would be, and I'm going to type this out, iverilog -o wire test _tb .vvp wire test _tb. Okay, looks like I made a mistake here. I got a syntax error on line 31, it says. Let's see what line 31's about. Oh, you know what I did wrong? I forgot to put a semicolon here. Okay. Now, it's really important, if I make any changes here, I have to save all again. Because if I try to run this without saving, it'll give me a different kind of error. You'll get an error that says no level modules and no option-s. This means that you have to save one or more .v files before running the command again. Okay. So let's run the command again. The same way you could do this on the Windows terminal, I can just press the up arrow key and give me the command again. I'm gonna run it. And it looks like it did it because if you look over here, I now have a .vvp file. Okay? That's what I was trying to make. It was this line here that created that .vvp file for me. Okay? Now we can run a simulation using the command vvp and the name of our vvp file .vvp. So I'm going to say vvp. The name of my vvp file is wire test underscore tb.vvp. I hope my camera doesn't get in the way of my terminal. That should be alright. Okay, so if you look in the terminal here, do you see it says wire test complete? That means it worked. And I also know it worked because it created a VCD file over here. Okay? So now we gotta analyze this using GTK Wave. Alright? Let's move my camera over here so that you can see my terminal. Now we have to enter the command GTK Wave. GTK Wave, like that. You gotta give it a second. There it is. So this is how we're gonna analyze our wires to make sure it actually works. You gotta click. You've got to click this hamburger icon here. You gotta click, hover over File, open new tab. All right. Then you click the VCD file that was created. Click open. Everything populates in here. Now we want to see our wires. Okay. So I'm gonna click this. I'm gonna select these. I can select more than one if I hold down Shift as I'm selecting. Okay. I'm gonna click append, and here are my wires. Okay. Now, what I should observe is that whenever whatever value A holds, B will hold the same value and C will hold the opposite value. That's how it works in Verilog. Okay. So as you can see, we start at 0 time. A had a value of 0. That means B had a value of 0 and C had a value of 1. We waited 20 nanoseconds, right? And then after that, we switched A to on. So A had a value of 1, B had a value of 1, C had a value of 0. We switch it again, and then we switch it again. So it looks like this wire is working exactly how we intended it. So if you got this far, congrats. You now did all of part A, okay? Now, it's up to you to do part B on your own, and hopefully you have enough knowledge that you can do it. So let's take a look at part B, okay? Use what you learned in part A to do the following. If your Lab1A folder is still open, you can close it by selecting the folder, clicking File, Close Folder. So File, Close Folder. Okay. Create a new folder in your CSE4010 Labs directory and call it Lab1B. Open this folder in VS Code. Now, here's what you gotta do. You gotta do this by yourselves. Create a module called WireTest2. It accepts 2 inputs instead of 1, okay? One called W, one called X, and then 2 outputs called Y and Z, okay? Set Y equal to the negation of X. Set Z equal to the negation of Y, okay? After that, you'll make another test bench called WireTest2 underscore TB that initially sets W and X to 0. You gotta wait 20 nanoseconds, set W to 1. Wait 20 more nanoseconds, set X to 1. Wait 20 more nanoseconds, set W to 0. Wait 20 more nanoseconds, set X to 0, okay? Add comments to both the module and the test bench. Compile and run using the proper commands, and then take a screenshot of your waveform, okay? So as promised, I did Lab1A for you. Now you gotta do Lab1B on your own, okay? And you probably have enough. I gave you more than enough. So Here's what you gotta do for the lab report. You're gonna use this lab report template here, okay? So the details of the report go here. The source code for labs A and B go here. The screenshots for A and B go here, okay? So for the report, you gotta say, what is Verilog? What is it used for? What is a module and a test bench? Write a brief and comprehensive description of what you've done and what you've learned, okay? You need the source codes for both of part A and B. And I need screenshots for A and B. And once you have that all typed in here with your name and student ID, tell me what lab this is. I would like it if you could export this report as a PDF and submit it to Canvas, and I will grade it. So, yeah, just over 30 minutes. Yeah, once you get that, that's it for Lab 1, and I'll see you guys in the next lab video. Thank you.